In this video, I'm going to show how to use Holdout method for binary choice variables. We have a spam dataset. Peter Derby works as a cybersecurity analyst at a private equity firm. His colleagues at the firm have been inundated by a large number of spam emails. Peter has been asked to implement a spam detection system on the company's email server. He analyzes a sample of 500 spam and legitimate emails with the following relevant variables. So the first one is the response variable, which is spam. And spam equals to 1 if the email is spam, 0 otherwise. The predictors are recipients, hyperlinks, and characters. Recipients refers to the number of recipients. Hyperlinks represents the number of hyperlinks in the email. And characters refers to the number of characters in the email. We are going to use the holdout method to compare the accuracy rates of two competing logistic models for spam. And we use first 375 observations for training and the remaining 125 observations for validation. The first model uses recipients, hyperlinks, and characters as predictor variables. And in the second model, we are going to remove the predictor variable that is not statistically significant in model 1. So let's start. First, we need to partition the dataset, and Analytic Solver is easy to use for partitioning the data, estimating models with the training set, and driving the necessary cross-validation measures. We generally use random draws for partitioning the sample data into training and validation sets. Here, for replicating purposes, I will continue to use the latter part of the sample data for validation set. We will partition using 75%-25% rule. 375 observations will be in the training set and 125 remaining will be in the validation set. Before we start partitioning, we need to create a variable called flag in column F. And we will type T for the first 375 observation. That is representing the training dataset. So you can copy T until here. And then remaining 125 will be V, representing validation dataset. You can copy down V. Now our dataset is ready to be partitioned. We select partition, standard partition, and the data range should be from A1 to F501. If not, you can click here and select the dataset. First row contains headers, is checked, and spam, recipients, hyperlinks, and characters are moved to selected variables. We will use partition variable under partitioning options, and for partitioning, we choose flag. We click OK. The STD partition worksheet now contains partition data with 375 observations in the training set and 125 observations in the validation set. Here on this STD partition worksheet, you are going to choose data mining and classify and choose logistic regression. Here recipients, hyperlinks, and characters are under selected variables and spam is under output variable. Success probability is 0.5 and click Next. We want variance covariance metrics and then click Next and then Finish. And here logreg output, we need to choose which coefficient is not significant because our second model will drop the insignificant variable from the model. So to do that, we are going to find the z-scores. First, we are going to find the standard errors of parameters. So the standard error of intercept is the square root of first diagonal element. The standard error of recipient is the square root of second diagonal element. So these are standard errors. Next, we calculate z-scores. And the z-score for intercept, coefficient estimate of intercept divided by standard error. And we drag down this formula and find out that all parameter estimates are significant except the character. So when we run the second model, we are going to drop the character. We will regress salary on intercept, recipient, and hyperlink. Before estimating the second model, let's check logreg validation score. And here you can find the accuracy or the percentage of correct, which is 68%. Now we will repeat the same steps for model 2. We have here STD, partition data set, and data mining, classify, logistic regression. This time we remove characters and click next. We don't need variance covariance matrix, and click next and click finish. In the log validation score 1 worksheet, you can see that accuracy rate for the second model is 65.6. Therefore, by converting the predicted probabilities into binary predictions and comparing them with the actual spam data, we find that the accuracy rates for model 1 and model 2 are 68% and 65.6% respectively. Based on these rates, we infer that model 1 is superior to model 2. Therefore, next step is you are going to re-estimate model 1 with all 500 observations to predict the spam probability with the number of recipients, hyperlinks, and characters, because your preferred model is model 1 with 3 predictors.